Hi, Mr. Luc.
Hello,
Can you
hello,
hear us
how are
today?
you? Can you hear me well?
Yes, we can hear you well. Thank you so much for joining us today. Whenever you're ready, you can take it away.
Thank you very much. And I'm extremely happy to be with you for the second time, actually, because I had the pleasure to be with you already in the past. From India this time, so apologies for being remote. But it's really a pleasure for me to be sharing the most recent trends about artificial intelligence and their application to the world that Schneider knows the best, which is the world of sustainability, energy management, and of course, Industry 4.0. So I'm going to spend the next few minutes to dive into this and hopefully to share with you the most recent innovation and the most recent trends that we have been observing in this world. But I would like to start by some principle as the principles generally guide our innovation and the deployment of our innovation. And I think at times when artificial intelligence is spreading all over the planet in many different applications, it's important to come back on one very important principle that keeps us together and keeps us efficient together, which is that machines are beneficial only to the extent that their action can be expected to achieve our objectives, which means that we can find at this stage any application, any machine, any application, or any artificial intelligence driven application that can find many purposes, but only the ones that are our purposes at the end find their way. And that's really a very important part of our work. And of course, I am quoting a very well-known researcher of Berkeley University who has defined this principle that is important to us as well at Schneider. Now, when I look at where we are today in developing AI application in the world of business, smart manufacturing, and energy management, there are four big dimensions into which we see more and more AI-driven application, not necessarily specific to our sectors. But I will start by customer satisfaction. We have more and more AI application in the interaction with our customers to make sure that we can find the best match or the best solution for our customer, learning from the customer cases, and also helping to enable to respond to our customers in a much faster, much smoother way. The second dimension that we have now across the board is more efficiency driven by AI, and it applies notably to our very big supply chain. Schneider Electric has one of the biggest supply chain in the world, and clearly recognized as becoming more efficient thanks to, of course, automation, but also thanks to application that are AI driven, notably to learn on the logistics and to make sure that we can provide solutions that are fit for purpose for our customers. The third one is, of course, sustainability. This is the core of the mission of Schneider Electric, to bring solutions for sustainability. And of course, sustainability is enabled by AI whenever AI enables people to have just enough resources for what they need. And this is taking a lot of learning, of course, and AI can help this learning. And the last but not the least is workforce enablement. Applying this to learning, applying this to anything that can be helping colleagues, teams to learn or to execute or to take an action that is AI enabled, of course, strengthen the human. And I think the best of AI is really strengthening human application. I'm going to dive a bit further into this, starting by the key industry challenges that we are seeing in these few years. The first one is that technology disruption is just a rolling fire. So clearly, any industry today needs to find a way through this technology disruption to pick the best of these technology disruptions for their purposes and their needs. And it takes, of course, a lot of effort to bring permanently the industry to the next generation. Second big challenge, of course, as we are all seeing these days, notably since COVID, 95% of the Fortune 1000 companies are hit by big supply chain challenges. So being able to serve the world from the world is an increasing challenge. And that's one we are facing as well in our sector. The third one is, of course, the one that the full planet is facing, which is the need to reduce 40% of the total carbon emission coming from the industry in the next few years to be altogether more sustainable. And the last one, clearly, is the fact that despite all odds, we are in shortage of competencies. So making sure that we enable more people is one of the critical challenges that the industry is facing. So how can AI respond to each of these challenges is what I'm going to dive further now. The first one, because this is the core and the motto of Schneider, is really energy transition. Research is saying that 1.3 trillion of savings can be done thanks to AI, and that's basically relying on the principle that when you measure, you understand what you are spending, and then you can take action on it. And the weakest point today of any infrastructure is that we are not understanding enough what is the exact use of energy that is needed by this infrastructure, and AI can really enable further the understanding and the learning about the usage of every infrastructure, and then helping to save more energy. The second element is that we can really count on the fact that the replacement cost on the existing install base can be really drilled down thanks to AI application, avoiding to create more capacity that would not be needed, because thanks to AI application, we would be more frugal in the way we use energy. The last, but not the least, of course, is that if we do not use this intelligent flexibility, the estimation of research is saying that it would, of course, represent an increased cost of 6 to 13% between now and 2040. So that's really a very strong enablement that is made possible thanks to AI. So more concretely, what does that mean for energy saving? Well, it means that the energy transition can be swift with the condition to be more coordinated. Most of the energy transition is made of going to renewable, and renewable is most of the time decentralized. Being decentralized, it is also more decarbonized, but being decentralized, it brings more intermittency and more instability in the way power, for example, is used close to the user, while the user himself can pilot more its generation and its usage of energy. All this needs more automation and more understanding of the deep needs of the infrastructure, and this is where AI can help. Of course, this transition requires significant investment, and this investment is underway, and I'm witnessing this investment in all the countries where I'm working. AI will be one dimension of this investment, maybe not the most visible one in terms of size, but clearly a key enabler in terms of technology to make these investments more efficient. So that's about the energy. Of course, the World Economic Forum has worked more deeply on how the principles for AI should apply to the energy transition. I'm not going to dwell on all the details of that, but for those who have an interest in this, I think this is good research, showing what are the key principles touching all the domains that are necessary to make it a comprehensive approach of AI in energy transition, touching the infrastructure, the principles of responsibility, the incentives, the education. I think this framework does exist, and it is very interesting to share, I think, as a good work who prepares the rollout of AI application in the energy transition world. Now, moving to another part of AI application in the industry, I would like to dwell more on how the whole industry is using AI, and that's one of the key aspects of that is how we structure data for the industry, and then how, based on the structured data, we build more AI lifecycle management and AI application. So in most of the cases that we have seen, AI application have started the industry by small application based on small data stacks. But as the time moves, it becomes more organized, and having data stacks that are well organized becomes more and more critical for each of the companies we are working with. That's what we call the data fabric, and clearly having homogeneous, well-organized data stacks within the companies becomes one of the key enablers of efficiency and AI enablement. based on which we can develop with these companies an AI lifecycle management, which really helps to reach the objectives of sustainability and efficiency that are key. Some of these elements, of course, have been already accelerated, and COVID has been a huge accelerator of needs from all kinds of industries. And we have had tons of examples over the last 2 years. Unfortunately, I should say, because of course, this has been a disaster to the planet. But as any disaster, it has forced everyone to take the challenge and to find solutions to respond to the challenge, to maintain continuity of operations. So here are 6 examples of things that are live, that have been deployed, including in Korea, such as unmanned operations, of course. We were, for our clients and for ourselves, in many circumstances, obliged to be operating plants without having people on the ground, or without having sufficient people on the ground. Collaborative design has become the rule, being all remote work from home. Having the ability to take data, make analytics at distance, not on premise, and to advise on how to guide the operations has been one of the accelerated applications. Augmented reality became a must in many applications to help notably people that did not have all the qualifications and training on the shop floor to get the information, the relevant information, and the advice from the system to guide them on the premises. Of course, there was more need to get all the relevant information transferred, treated, displayed, and analyzed in remote unified operation centers. And the last but not the least was certainly to be able to train people in digital in order to avoid the number of people going on site for the real training. So these 6 domains of application, all of them being AI enabled, have been really accelerating extremely fast during the COVID period. Now, where are we heading to in terms of next generation of smart manufacturing? I think we are moving gradually to data-driven and software-based automation. Schneider Electric is in automation since decades, of course, and we have a full stack of technology in all the components of automation. Clearly, the next mile and the one on which we are at the cutting edge is really to go on data-driven software-based automation. That means, of course, innovative software and services, being able to serve in remote everything, and of course, something that is much more open, partner-oriented, and hardware agnostic than anything that did exist in the past. It has always been one of the principles of Schneider to have openness, partnership-oriented, and agnostic, but it becomes a golden rule really for the future. There are, based on this, a number of key trends that we are seeing on the market and that we'd like to share, which we call the 4 big integrations. Data is going across all the silos and across all the systems, and is driving more integration. And I would like to share them. The first one is that energy and automation in industry are now coming together. They used to be operated in silos inside of most of the industries. Based on the sustainability agenda, the acceleration of needs for decarbonation, and the needs for efficiency, now we are facing really an acceleration of energy and automation coming on a common data environment, common automation data environment, which is really driving more efficiency. So that's one key trend that we are seeing with very direct benefits that we can measure now statistically on the industry, from the CapEx to the OpEx cycle, with benefits that are up to 20% of saving of all the electrical control and information layer of the CapEx for the industry, up to 20% savings. Process energy usage improvement up to 10% of the process, a downtime reduction up to 15%, sometimes much more than that. And of course, an improvement of profitability, which makes the business case of this investment up to 3 points. So that's the concrete outcome of this integration of automation and energy that we see more and more in the industry. The second big integration is the integration between the endpoint and the cloud. We used to have in the industry everything on the endpoint. We then had more and more development of the cloud, and now there is a coexistence in a seamless way between what is done in the cloud and what is done in the edge, and a need to be permanently moving from one to the other, and that's really being more and more integrated. That's how basically digital enables the empowerment of people in the shop floor, based on information or intelligence that can be sitting in the cloud, or based on computation that needs to remain close to the machine at the edge. The third integration is the integration on the life cycle. There used to be silos on all kinds of infrastructure, industry, building, between the phase of design and build and the phase of operations and maintenance. We go more and more for a full digital twin approach that is enabling to follow the same infrastructure and the same operations for the entire life cycle. That's what AVEVA in Schneider Group is doing, providing solutions that are enabling to have a full digital twin from the design phase down to the maintenance, and of course following the full operation cycle also with the same digital environment. This enables AI, for example, to rely on a very precise and very stable data lake, and of course to accelerate the number of applications that we have. So typically that's an illustration of what I just said, saying that AVEVA, for example, is taking all the elements of data that are present in the digital twin of the infrastructure of the factory, basically, or series of factories in some case, and then based on the PI system of OSIsoft, is collecting all the data and organizing all the data infrastructure of the operations of these factories, so that they remain on one data stack that is very well organized and kept, so that whenever the need comes, the extraction of this data for operational purposes, for analytical purposes, can be made in a very reliable way and in a very stable way over time, which is the criteria for performance. The last integration, which is also very important, is the side-by-side to integrated company. We used to have in all industries an optimization of everything at the site level. More and more, always driven by the need for more sustainability and the more efficiency at corporate level, there is now a need for an integrated company management of some key KPIs, notably carbon, but not only carbon. So clearly, this integration between the side-by-side and the integrated company is the fourth very big trend of integration. So that's what leads typically to this kind of unified operation center that AVEVA does, where you can see that all the sites of one company would be just pulled out in terms of information and data and displayed in one single place to be able to monitor all the performance of the company at once. So that's the four big integrations. Now, I would like to finish by giving an example of how these things can come together in just one application. We have hundreds, but I think it always illustrates better when you give one example that can hit the ground somewhere. So this example is one of our EcoStructure, which is the IoT-enabled ecosystem of Schneider Electric, autonomous production advisor. So that's one of the applications of Schneider Electric that we apply to reduce operation costs. That's AI enabled, of course, and the objective of this AI enablement is to really unlock business value on production sites. The objective is, of course, based on the information that we collect from the shop floor. Sorry if the slide is drifting. We look at the operation cost KPI that can be optimized. We dive into the equipment lifetime modeling so that we can increase the equipment lifetime by detecting, for example, early signals of fatigue of some equipments, predicting anomalies so that the machine learning algorithm can detect these kind of elements early enough and intervene early enough to do predictive maintenance on these equipments. Then the third element is to capture expertise and domain knowledge that would be applied to machine learning models, which means that it would not be a one-size-fits-all application for all sectors. It would be customized by sector of industry, depending on what matters for a sector of industry. And the last, but certainly not the least, is that thanks to this learning, the safety record is improving because it provides much more information and learning on the actual usage of the factory. So that's an example of this application, which takes the data of the platform and runs it with these purposes. So we apply it to a rod pump analytics application, and it basically works like this. We bring together the data, then the controller runs the machine learning models on this data. The models will be then enhanced and retained by the operator based on the sector knowledge, based on the business knowledge that he has on this typical rod pump exercise. Then we close the loop so that we can lead to a full autonomous control. And then the machine learning models can be shared between all the oil and gas well of one specific customer, for example. So we applied that for one client in Southeast Asia, for which the challenge was to optimize the oil pump operations in a remote location where they did not have enough experienced operators. So it was basically how to collect and share the knowledge of the experienced operators, and then from there to build models that can be shared to other sites where they have less experienced operators. So the first phase was to capture the expertise from their senior operators in order to get this expertise guiding the machine learning models. The second stage was to manage the asset lifetime with less interventions. And the third element was clearly to optimize production by reducing the unplanned downtime and maximizing all volumes. So the outcome for this client has been 13% of increased production, 34% of reduced energy consumption. And of course, they reduced the frequency of abnormal events and the extent of and they extended the equipment lifetime, and they increased the accuracy of fault detection. So that's in a nutshell how one application based on AI drilled down to something that is customized for a given sector, oil and gas in that matter, based on learning of the specific needs of one client, have been applied and with a very specific outcome for that client. I will finish here my presentation by just a very short conclusion, which is that our learning about now dispatching AI applications across the planet with more and more clients using this, sometimes without knowing that this is AI embedded, is really that what matters the most is to be able to work on very well organized, very clear data stacks. And that's why we pay a lot of attention at Schneider to continue to enhance our proposition, thanks to SIsoft, to be able to organize the data of industry in a much more reliable and stable manner. Because based on that, most of the industries are then able to increase and to leapfrog their level of automation and to get the benefits of it, which is primarily efficiency on the industry process side and sustainability, thanks to much more accurate way of predicting and using the energy, both of them contributing to a much more efficient economy of the industry and of course to a much more sustainable way of operating as industries. So that's what I wanted to share with you in a nutshell today. Thank you again very much for inviting me for the second time. It's always a pleasure to be digitally, at least with Korea, waiting for long for the opportunity to come back to your beautiful country. Thank you very much.
Thank you very much, Mr. Luc, for your presentation. Is it possible for the audiences to ask you some questions, Mr. Luc? Okay.
Of course, with pleasure. Of course, with pleasure. No problem.
Okay, thank you so much. We have some questions from the online audiences. The first question we have is, since COVID-19 pandemic, contactless business has come into the global spotlight. How did this situation affect AI? What are the effects on industry due to work from home or hybrid work trends and other AI-related business environmental changes?
So it has brought opportunities to AI-driven application, and that's the reality. I was sharing some of them earlier in my presentation, and clearly these opportunities were based on many industrial situations, including ours in our 200 factories, where we were not able to operate normally, but we still needed to serve our customers, of course. And as the duty to serve our customers is, I think, a common duty to all companies, we were pushed to innovate faster. We had a very good application, for example, in Korea. The first place where we deployed was in Korea, was to bring a touchless application to one of our customers because they needed to be able to operate, but they couldn't touch the machine. So this one was not necessarily AI driven, but that's a typical application that is post-COVID. And it took us a few weeks to deploy that application. And based on the elements that we had, we brought the relevant information to the people working on the shop floor so that they could operate just from their smartphone and didn't have to touch any more the machine. So that's a typical need that arises from a COVID crisis type of situation. But we have many more, and of course, more situations where AI enabled, because essentially when we were lacking information due to the fact that we had less people on the shop floor, from there, it was typically the case that I spotted with this Southeast Asian oil and gas company, was because they could not send their experts anymore to their sites. So for this, you need to find a way to extract relevant information, and the best way to extract relevant information when it's human-based is machine learning. So that's how we enable this company to hopefully, well, the numbers are there, but to hopefully do a better job than what they could do due to the COVID constraints.
Thank you so much for your answer. We have our last question today. I'll ask you in Korean, and translator will translate it for you. 저희 실시간 질문 중에서
So
한국어 질문
actually,
하나
well, there
마지막으로
is
드리고
the one last question. I'm going to deliver that question in Korean.
스마트 팩토리의
So
설비
in
유지
smart
보수에서
factories, facility
고장
repair and
데이터는 그
maintenance,
발생 빈도나
it is
지속
difficult to
시간
collect
면에서
meaningful
유의미한
data
양해
about
보이기
failure.
어렵습니다.
So how can
어떻게
we
AI를
apply
예지
AI
보전에
to
적용할 수
predictive
있을까요?
maintenance of a smart factory?
I'm sorry, I didn't get the translation. So.
Oh, sorry, you didn't get the translation.
Yeah, I'm sorry.
All right, then we'll ask you an English question for our last question.
I'm sorry for that, really.
No, I'm sorry. Okay, our last question for you is how AI can be an additive contributor of business growth.
Well, I think whenever you extract benefits, I will come back to the first quote, whenever you extract benefits for the user, it means that there is a business benefit. And I really think from our experience that the first business benefit that can be enabled by AI is really on the energy side, because the biggest challenge of energy, of course, we all talk about energy transition from carbonized generation to decarbonized generation. But this transition is probably only 40% of what we can do to decarbonize. Most of the decarbonization can be made on the user side. And this user side needs understanding on what is the actual use of the user. So to give you an example, most of the buildings are built for a predefined theoretical usage, but most of the buildings are not used as per the design. And the difference between the optimized usage from an energy standpoint of the building and the usage that was predefined and with which most of the time the energy generation is matching can be 75%. And the difference can be matched by observing the true usage of the building and adapting permanently the just needed level of energy that is needed for this building. And we are talking about 30% to 75% savings most of the time. So that's one example. And of course, it represents actual savings, which means that there is money at stake. And this money at stake is a business. So that's one example in energy, but I could find, of course, many other examples in the process efficiency side, because it goes the same way. And when you bring both together, of course, it makes a business at the end, which is enabled by AI and technology, and the benefits goes to the operators, to the user, basically.
Thank you so much for your answer today. All right, we hope to see you again next year. And thank you so much for your presentation today. Thank
Always
you,
a
Mr.
pleasure.
Luc.
Thank you very much.